Today we shall talk about microwave tubes. Before starting about your microwave tubes, you will carry out what are the disadvantages of using conventional tubes. We have got plenty of conventional tubes such as triode, pentode, petode, like that. You have got plenty number of tubes. Some of the high frequency effects of conventional tubes are listed below. The conventional tubes are, when you start increasing the frequency in the conventional tube, what happens is the functionality of the conventional tube produces plenty of side effects such as your interelectrode capacitance effect, lead inductance effect, transit time effect, gain bandwidth product effect, effect due to RF losses, effect due to radiation losses. We will talk one by one. Before starting your tubes, we have to have a broad knowledge about what are the conventional tubes and what are the disadvantages of previous slide. Disadvantages of the conventional tubes. When you talk about the lead inductance effect, usually any microwave circuit will work at resonance. When it is based on an LC circuit. Based on the LC circuits, as your frequency increases, the component of LNC should be varied in such a way the LC component is being achieved. Now when you talk about your interelectrode capacitance, as your frequency increases, what happens is the capacitance due to the connection of the tubes produces parasitic capacitance. This parasitic capacitance will start to increase as frequency increases. When your frequency increases, what happens is this diode will act as a parasitic capacitance. When this diode acts as a parasitic capacitance, this will produce larger effect which reduces the power efficiency of the tube. When we talk about how to reduce this tube, we have got a formula called C is equal to mu naught mu R A divided by D, where you can just reduce this parasitic capacitance by using either by decreasing the area or by increasing the distance between the tubes. The second one, when you talk about lead inductance effect, this also causes, as your inductance, as your frequency increases, the number of coils will also be increased, right? And this can be reduced by decreasing the distance. And when you talk about the transit time effect talks to you about what is the distance traveled by the electron from the cathode to the anode. When the electron travels from the cathode to the anode, what happens here is the distance should be minimum. When your distance is minimum at low frequencies, what happens is as your frequency increases, the gain and your current and your voltage in phase. When you talk about higher frequencies, what happens here is the current lags the voltage. When your current lags the voltage, the time of transit time effect comes into the effect, and this can be reduced by reducing the area. This also in turn governs with interelectrode capacitance effect and gain bandwidth product effect. This gain bandwidth product effect is independent of frequency and it depends on capacitance. This also, the size of the capacitance should be very, very minimum. Like this, your RF losses and radiation losses are also governed. Next. Now generally your microwave tubes can be classified into two major categories. One is on linear beam tubes, another one is on cross field tubes. These linear beam tubes can be called as O tubes, and this cross field devices can be called as M type tubes. And linear beam tubes can be divided into klystron, travelling wave tube, twistons. And these klystons can broadly classified into two cavity klystons, multi cavity and reflex klystons. When you talk about twistons, it can consist of helix, backward oscillator and couple cavity and ring bar or link loop it can be. And you are talking about your magnetron, it can be divided into M type category and it is cross field amplifier and senetrons. And when you talk about what is the major difference between this O type and M type is where the electric field and the electron beams velocity are parallelly going with each other, they are linear in nature. Whereas if you talk about this cross field device, the magnetic field and electric field are perpendicular to each other. Next. Now we will talk about two-way klystron or two cavity klystron. It consists of two cavities. The basic construction of this tube is it consists of an electron gun. The electrons are focused using your focusing electrodes, and you have got two cavities. One is called buncher cavity, another one is called catcher cavity, and this is being supplied to an beam voltage. And as the electron focuses through the gap A, you have got two gaps, gap A and gap B, and you have got drift space in between the gap between two devices, input cavity and the output cavity. There is a drift space and where the bunching of electrons takes place. This is about the general construction of your two cavity klystron. Next. This is one diagram which shows you how your input signal is being increased. Just move on to the next one. Next. This operation can be explained using an Applegate diagram. What is this Applegate diagram? When you talk about this Applegate diagram, this gives you a nature about, we will talk about three electrons. One is called early electron, reference electron, late electron. Let us give an example for this. We will assume three candidates who is coming from Avadi. One is coming by bicycle, one is coming by walk, and another is coming by motorcycle. Let us assume all these guys has to reach the college at the same time, right? Then one comes with what comes by walk takes longer time period, and one comes with the bike takes a reference time period, and one comes with the bike which comes up faster. And we will compare all these three terms with that of the electrons. Let us assume the electrons B dash. This B dash is not affected by RF voltage. Then it travels with a constant velocity, right? And then we will assume this is called as early electron. C dash is called as early electron. It is subjected to maximum velocity. Then the bike can travel more faster. I am just comparing with the three analogy what I have given. One is called reference electron is considered as one is coming by bicycle. Late electron is nothing but the person who is traveling by motorbike, and the early electron is the person who travels by walk. It has to reach the college at the same time. This reaching the college is called as bunching of electrons. Here velocity modulation takes place in such a way that the velocity of the electron is varied in accordance with the RF signal. Based on the RF signal, the velocity of the electron is varied, right? The velocity of the electron is varied in the RF signal, and you will get bunching of signals, bunching of electrons, bunching effect takes place. This is called as velocity modulation. The definition of velocity modulation is that the velocity of the wave or the velocity of the electron is varied in accordance with the RF signal. As you have told, early electron, reference electron, and late electron. Reference electron is not affected by your RF voltage, and your early electron is affected by your RF voltage, that is your negative voltage, so that it has to travel longer distance and it reaches the gap. Bunching here takes place. The bunching of electrons, bunching of these electrons, bunching will take place once in a cycle. The bunching will takes place once in a cycle. When it takes once in a cycle, it's happened that it can be produced. The bunching of electrons are produced, and when it travels from the bunching of electrons happens only in the drift space. When it happens only in the drift space, what happens is we have to bunching of electrons causes your velocity modulation to be converted into current modulation, so that you can just see previous slide. Here you can see as bunching of electrons happens, as at the point of bunching of electron, it gives away the energy to the RF energy, so that amplification takes down. This is one bunching point. Second bunching point, you can see how the electron amplitude is being increased, right? This is how your two cavity klystron works. Okay, sir, okay?